So miscellaneous first sum is about a cube wherein there are 4 diagonals. Diagonal 1 is AI plus AJ plus AK. Diagonal 2 is AI minus AJ plus AK. Diagonal 3 is AI plus AJ minus AK. Diagonal 4 is AI minus AJ minus AK. These are the 4 diagonals. There will be a line Li plus Mj plus Nk. This is alpha making an angle, this is making an angle beta, this gamma and delta. And you know cos of alpha is dot product of this vector dot this vector by magnitude of this and magnitude of that. So Al plus Am plus An by root 3a into root of L square plus M square plus N square. Similarly, you will have a cos beta which is Al minus Am plus An dotting the diagonal 2 and the line, and diagonal 3 and the line. Like that you do, you get by a root 3a into root of L square plus M square plus N square. And a cos gamma is Al plus Am minus An by root 3a into root of L square plus M square plus N square. And a cos delta is Al minus Am minus An by root 3a into root of L square plus M square plus N square. So when you do this, you see A will get completely cancelled, and so you will be left with a L plus M plus N by root 3 into L square plus M square plus N square. Get a L minus M plus N by root 3 into root of L square plus M square plus N square. Then you get a L plus M minus N by root 3 into root of L square plus M square plus N square. And you get a L minus M minus N by root 3 into root of L square plus M square plus N square. So when you do this and you square cos square alpha, cos square beta, cos square gamma, cos square delta, you will square all this and you will end up getting a 4L square. LCM will be the same, which is 3 into L square plus M square plus N square will be the LCM. And 4 L square plus 4M square plus 4N square. So 4 times L square plus M square plus N square, which is 4 by 3. So the next question, find the equation of a plane which is perpendicular to other planes. And if you want to find the equation of this plane which is perpendicular to other planes, you just cross these two planes. You get the equation of this plane. Just cross it I, j, k, 2, 3, minus 2, 1, 2 and a minus 3. Just cross it, you will get a 5 x minus 4y plus you get a 5i minus 4j minus 1k as a vector. And so you can copy this as 5x minus 4y minus 1z is equal to d, the equation of this plane. So then to find d, a point on the plane satisfies the equation of plane. The question has 1 comma 1 minus 1 comma 2. So 5 into 1 plus 4 into minus 1 plus minus 1 into 2. This itself will give you 7. So this you find d, and so then replace it, a 5x minus 4y minus 1z is equal to 7. Give you the equation of the plane. Okay, once again. So the next is 29th sum. You have to learn properties to do the sum, so obviously that will be omitted. There is no properties in determinants. So 30th question, find the coordinates of the point through the line. Find the equation of a line 3, 4, 1, 5, 1, 6. Read the question from the textbook. X minus 3 by 5 minus 3. Write the equation of the line. Okay. So next is y minus 4 by minus 3 is equal to z minus 1 by 5 is equal to lambda. Okay, find the equation of this line. Then write what is x is 2 lambda plus 3, y is minus 3 lambda plus 4, z is 5 lambda plus 1. And you know this line is crossing xy plane, which means z coordinate will be 0. If you put z as 0, you get lambda as minus 1 by 5. Re-substitute back, you get x is equal to the coordinates 13 by 5. In the place of lambda, you substitute this and calculate y will be equal to 23 by 5 and z will be equal to 0. So this is the point of intersection between the line and the plane. That is, find the coordinates of the point where the line through the point crosses the xy plane. This line is crossing an xy plane, and this point is what they are asking. So I am sure you understood that. So let's go to 11th exercise 11. Show that the line joining the point origin and a point 2, 1, 1 is perpendicular to another two lines has been given, okay, which is 3, 5, 1 minus 1 and 4, 3, minus 1. Line through 2 points is x minus 0 by 2 is equal to y minus 0 by 1 is equal to z minus 0 by 2 is equal to lambda. X is 2 lambda, y is 1 lambda, z is equal to 2 lambda. Now coming back to this line, it's x minus 3 by 4 minus 3, y minus 5 by minus 2 is equal to z plus 1 by 0. Okay, so that will be this line. You can't equate both the lines to lambda, so you can equate it to mu. So x will be 1 mu plus 3. Okay, why am I doing that? Why should you find x, y and z? You don't have to find x, y and z. Okay, just leave it like this. They're asking that the two lines are perpendicular to each other. Just take the b vector. This is the b1 vector and this is your b2 vector. So b1 vector dot b2 vector is equal to 0 is a condition for perpendicular. So dot it at 2 minus 2 plus 0. Yeah, it is 0. So they both are perpendicular. So this is your b1 vector. You should write 2i plus 1j plus 2k is your b1 vector. So b2 vector, which is 1i minus 2j plus 0k. So then therefore you can dot them and write. So let's go to second question. L1, M1, N1, L2, M2, N2 are the direction cosines of two mutually perpendicular lines. Okay, we have to find a direction cosine of a line which is perpendicular to both of this. Just cross it. It's a scissors. You need a vector which is perpendicular to both of this. You just have to cross it. I, J, K, L1, M1, N1, L2, M2, N2. Just cross it. M1 into N2 minus M2 into N1 minus J into L1 into N2 minus L2 into N1 plus K vector into L1 into M2 minus L2 into M1. So you just simply cross it, okay, and you get this to be the direction cosines. No, actually this should be with the plus sign, so you have to interchange this. And the direction cosines are M1 N2 minus M2 N1 is one direction cosine, L2 N1 minus L1 N2 is another direction cosine, L1 M2 minus L2 M1 is another direction cosine. So hence proved. The thing is, when you cross two direction cosines, you will only get a direction cosine. Since these are given as DCs, the answer you get is also a DC, that's all. So let's go to third question. Find the angle between the lines whose direction ratios are, one direction ratio is ABC, which is AI plus BJ plus CK, write it. Next is B minus C minus A, C minus A and A minus B, right? B minus C into I plus C minus A into. So then dot product of this vector, any angle between the two is dotting the two. So A into B minus C plus B into C minus A plus C into A minus B by root of this vector, which is A square plus B square plus C square, the root of this vector, which is B minus C the whole square plus C minus A the whole square plus root of A minus B the whole square. That's the angle between the two, cos theta is equal to. So when you take it in, it will become 0. So then therefore the angle between them becomes 90. But you should write it as AI plus BJ plus CK. This vector is B minus C. You should write it in vector form and then dot it, okay. So let's go to fourth question. Find the equation of a line which is parallel to x-axis. Yeah, this is like this. But it's passing through the origin, which means it's x-axis only. Equation of a line which is parallel to x-axis but passing through the origin, it's x-axis only. So normally it will be like x minus 0 into A is equal to y minus 0 into b is equal to z minus 0 into c, any equation of line considering arbitrary point, right, x, y, z. But you don't know what is a, b and c. A, b and c are nothing but the direction cosine, which is also cos alpha, cos beta and cos gamma. Cos alpha into I plus cos beta and z, that's also direction cosine. So look at this line, the line which is nothing but the x-axis is making an angle, alpha is 0, beta is 90 with x-axis and gamma is also 90. So then therefore cos 0 will be 1. So it's x by 1 is equal to y by 0 is equal to z by 0 is equal to 1, and this is the equation of the line. Very, very important question. So you have to find the direction cosines for it. So fifth question. If the coordinates, 4 coordinates are given a, b, c, d, position vectors, you have to find what is ab vector, what is cd vector. How do you find ab vector? It's x2 minus x1 into I. So 4 minus 1 into I, 5 minus 2 which is 3j, 7 minus 3 which is 4k. And then you have to find what is CD vector, which is D minus C, which is 2 plus 4 into I plus 9 minus 3 into J plus 2 plus 6 into K. So find AB vector and find CD vector and find the angle between them. Dot product of the two vector by magnitude of AB into magnitude of CD. So you know this. So I am not doing this sum. So sixth question. Prove that the two lines are perpendicular to each other. B1 vector and B2 vector, or what is the denominator? You should write B1 vector is minus 3I plus 2kj plus 2k. B2 vector is 3ki plus 1j minus 5k. So dot product is 0 if they are perpendicular. So minus 9k plus 2k minus 10 is equal to 0. So minus 7k minus 10 is equal to 0, minus 7k is equal to 10. So k is equal to 10 minus 10 by 7. So you have to dot product them and find the answer. I hope I've done it correctly. 3 which is 9 plus 2k minus 10, yeah, is equal to 0. Yeah, thus you find the value of k. Okay, so let's go to 7th question. Find the vector equation of a line passing through the point 1, 2, 3 and perpendicular to the plane. In a plane சம்பந்தம் ஒன்றுமே கிடையாது, பிளேனில் இருக்கிறது பிளேனோட நார்மல். ஸோ யூ கெட் அ 1, 2, minus 5 to be the direction. You have a plane's equation, right? That itself is nothing but a normal. So thus you can write the equation of the line, which is x minus 1 by 1 is equal to y minus 2 by 2 is equal to z minus 3 by minus 5 is equal to lambda. X minus 5 by minus 3 is equal to lambda. The vector equation is what they are asking. R vector is equal to a vector plus lambda times b vector, the point vector, which is 1i plus 2j plus 3k, plus lambda times the direction vector 1i plus 2j minus 5k. So that's the equation of the line. So let's go to 8th question. Find the equation of the plane which is passing through the point a comma b comma c and parallel to another plane which is 1x plus 1y plus 1z is equal to 2. I am writing it in vector form, not the given vector form, writing directly in Cartesian form. I know both of them are parallel, which means their normals are the same. So you can copy the same direction, dr's normals, 1x plus 1y plus 1z is equal to d for this equation. And the point on the plane satisfies the equation of the plane, so resubstituting back x plus y plus z is equal to a plus b plus c. So let's go to 9th question. The shortest distance between the line, two skew lines. When r vector is equal to a1 vector plus lambda times b1 vector, next r vector a2 vector plus lambda times b2 vector. The two lines are given in vector form. You know what is a1 a2 b1 b2? Just the shortest distance between two skew lines is like a2 minus a1 dot b1 cross b2 itself is 0. b1 cross b2 itself is 0. That is, the distance between two skew lines is 0. Distance between two skew lines is b1 cross magnitude of b1 cross b2. But if the no distance is 0, the denominator goes away. That's why the formula is just a2. This is the condition for two lines to be coplanar. So then substitute the formula, do b1 cross b2 and dot it, you get the distance. Okay. Even if you get negative, you should write positive answers. It's because it's distance. So 10th question. The coordinates of the point, the line through the point 5, 1, 6 and 3, 4, 1 is cutting the yz plane, which means x coordinate will be 0, right? So x minus 5 by 3 minus 5 is equal to y minus 1 by 4 minus 1 is equal to z minus 6 by 1 minus 5 is equal to lambda. So just find what is x minus 2 lambda plus 5, y is equal to 3 lambda plus 1, z is equal to minus 5 lambda plus 6 and x itself is 0. So you get lambda is equal to 5 by 2. Resubstitute back and you get the value of x, y and z. That's all. So similarly you have 11th question which is cutting through zx plane, which means the y coordinate is 0. So you can do the same thing for that sum also. So 12th question, find the coordinates of the point. Okay, 3, minus 4, minus 5 and 2, minus 3, 1 is a line. So x minus 3 by 2 minus 3 is equal to y plus 4 by minus 3 plus 4 is equal to y plus 5 by 1 plus 5 is equal to lambda. And this line is crossing a plane and the plane's equation is 2x plus y plus z is equal to 7. So as usual, find what is x is minus 1 lambda plus 3, y is 1 lambda minus 4, z is equal to 6 lambda minus 5. It's not crossing xy plane, it's crossing this plane itself here for a change. So then therefore this x, y and z, which is an arbitrary point on the line, will lie on the plane. So point on the plane satisfies the equation of plane. Substitute in the plane 2 into minus 1 lambda plus 3 plus y itself is 1 lambda minus 4 plus z itself is 6 lambda minus 5 is equal to 7. Just substitute in the plane. You get x, y and z from the line. Get the line's equation. Okay, when it is intersecting with any plane, any line intersecting with a plane, just write the equation of plane. Get what is x, y, z. Substitute it in the plane. Normally when it's lying in it's cutting through xy plane, you write z as 0. XZ plane, you write y as 0, but here it's passing through a plane itself. So point on the plane satisfies the equation of plane. So get the value of lambda and resubstitute. Get the value of lambda, resubstitute here in x, y and z so that you get the point of intersection between the line and the plane. That's called a point of intersection between the line and the plane. You know, that means it's like this, a line is crossing the plane and we are trying to find the point of intersection. So get the equation of a line, which is x minus 3 by minus 1 is equal to y plus 4 by 1 is equal to z plus 5 by 6 is equal to lambda. Get right what is x, y and z in terms of this, and then put it in the plane where point on the plane satisfies the equation of plane. So, and we get the value of lambda, resubstitute back. I hope I'm clear. Very, very important concept, point of intersection. 13th question. The equation of the plane passing through the point minus 1, 3, 2 and perpendicular to, equation of plane passing through this and perpendicular to other planes. I've told you, any plane perpendicular to the planes, you cross this and this planes, which is I, J, K, 1, 2, 3, 3, 3, 1. Just cross it, you get a vector. Write it as this equation of the plane itself is equal to D, and a point on the plane satisfies the equation of plane. You get the actual plane dealt with a similar sum in example. So just continue with that. If the point 1, 1, P and the point minus 3, 0, 1 are equidistant from a plane, they are the same distance. Let's do, you know what the plane's equation is, 1x plus 2y plus 3z is equal to 5. The distance between a point and a plane formula is ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c squared is the distance between a point and a plane. So then let's do the first distance d1 and do the second distance. D1 itself is 1 into 1 plus 2 into 1 plus 3 into p minus the distance 5, yeah, by root of a square plus b square plus c square, which is, you know, this is like ax plus by plus cz is equal to d. So you know what is a, b and c? It's 1 plus 4 plus 9. So you get 8 plus 3p by root 14 to be the distance 1. Let's do the distance 2. What is distance 2? It's with this point. So 1 into minus 3, which is minus 3, plus 2 into 0 plus 3 into 1 minus 5 by root of a square plus b square plus c square root 14. So 3 and 3 get cancels, 5 by root 14. So you get it as 5 by root 14, is it correct? Minus 3 plus 3. Okay, ax1 plus by1 plus cz1 minus d, did I write that? 1 into 3 plus 2 into 0 plus 3 into 1 minus 5. Yeah, so you get a 5 by root 14 as a second distance. Equate both the distance, 5 by root 14, you know this and this will get cancelled. And there is a mod on both sides, which means the answer can be plus and minus. So 8 plus 3p can be 5 or 8 plus 3p can be minus 5. So 3p is equal to minus 3 and 3p is equal to minus 3 minus 8 is minus 13. P is equal to 13. No, 3p is equal to, p is equal to minus 13 by 3 or magnitude of it, because it's a perpendicular distance and this is an unknown value, right? Okay, let's see what is the answer for this sum in the book back. Chapter 11, 14th sum. Chapter 11, miscellaneous, 14th sum. Yeah, you are supposed to get p is equal to minus 1. Okay, the book back answer is not correct. Okay, so it's p is equal to minus 1, p is equal to minus plus 13, p is equal to minus 13 by 3. These are the answers I'm getting. I hope I've not done any mistake, calculation mistake, you check it out, okay. So the next one is 15th question. Find the equation of plane passing through line of notebook format, line of intersection, p1 plus lambda times p2 is equal to 0. So 1 plus 2 lambda into x plus 1 plus 3 lambda into y plus 1 minus 1 lambda into z minus 1 plus 4 lambda is equal to 0. Thus you get the equation of this plane and it's parallel to x-axis. Imagine a plane is parallel to x-axis. A plane does not have anything other than the normal, and its normal is going to make a 90 degree with x-axis. Cos, therefore you also know it's cos alpha into I plus cos beta into j plus cos gamma into k plus distance, yeah. And this is cos 90, cos 90 itself is 0, therefore you know the x coordinate is becoming 0 because the plane is defined by its normal. So don't get deceived by the fact the plane is parallel to x-axis, the plane's normal is along perpendicular to x-axis. So then cos alpha is 0, so 1 plus 2 lambda itself is 0, lambda is minus 1 by 2, get lambda and resubstitute back, you get the answer for lambda. You get the equation of the plane itself, I'm sorry, once you get lambda. So let's go to next question. Please do the sum and verify your answer. Okay, 16th question. If O is the origin 0, 0, 0, P is the point 1, 2, minus 3. Find the equation of the plane passing through, I have to find the equation of plane which contains P and which contains O. And you know this is nothing but the normal. It's 1, 2, minus 3, 0, 0, 0. The normal itself is 1i plus 2j minus 3k, and the plane is defined by its normal. So 1x plus 2y minus 3z is equal to d. Then a point on the plane can satisfy the equation of the plane. So you can write this point itself as 1 plus 4 plus 9 is equal to d. So 14 is equal to d. So resubstitute back, 1x plus 2y minus 3z is equal to 14 becomes the equation of the plane. So it's very simple, right? So then if you don't draw, you can't get the answers correct. Find the equation of plane containing a line of intersection. So again 1 plus 2 lambda into x plus 2 plus 1 lambda into y plus 3 plus minus 1 lambda into z minus 4 plus 5 lambda is equal to 0. I got the equation of the plane in terms of lambda. I need to find lambda, but it's perpendicular to another plane which is 5x plus 3y minus 6z plus 8 is equal to 0. These two are perpendicular, which means the dot product of the direction ratios have to be equal to 0. a1 a2 plus b1 b2 plus c1 c2 is equal to 0. You can ignore the distance. So a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So 5 into 1 plus 2 lambda plus 3 into 2 plus 1 lambda minus 6 into 3 minus 1 lambda itself is 0. Get lambda, resubstitute back, that's all. So let's go to 18th question. Find the distance of the point minus 1, minus 5, minus 10 from the intersection of a line and a plane. Okay, you have to write the equation of the line. You have to write it in Cartesian form, not in vector form. So x minus 2 by 3 is equal to y plus 1 by 4 is equal to z minus 2, z minus, 2 minus 1 and 2 are the points. 2 minus 1 and 2. So z minus 2 by 2. So convert the line, vector form of line into Cartesian form of line, put x equal to lambda. Okay, so then you can find what is x, y and z. Then substitute that in the plane's equation. 1x minus 1y plus 1z is equal to 5, and then with the value of lambda, resubstitute back so that you get the point of intersection between a line and a plane. I have already dealt with the sum. Remember, we dealt with the sum where we found the point of intersection between a line and a plane here. This separate part. Apart from that, you also have to find a distance between an external point and that point of intersection. Okay, this is not a perpendicular distance. So you have to find the point of intersection. How do you find? It's 3 lambda plus 2. Y is equal to 4 lambda minus 1. Z is equal to 2 lambda plus 2, and that's this x, y and z. It's intersecting with the plane, so point on the plane satisfies the equation of the plane. So 3 lambda plus 2 minus 4 lambda minus 1 plus z is 2 lambda plus 2 is equal to 5. Then with this you find lambda. Then substitute it here, get the point. Once you get these points here, you can use an ordinary distance formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square to get the distance. Very, very easy. So distance between a point and the point of intersection between a line and a plane. So it's extra. So this sum is more important. No, this itself is important. On the top of it, they are asking some distance. You cannot take it as perpendicular distance because it's not between a point and a plane. It's a point and the point of intersection between a line and a plane. So do this point of intersection between a line and plane, get this point. Okay, for which you should write the Cartesian equation of line, Cartesian equation of plane, get y, x, y, z from the line equation, substitute that in the plane, get the value of lambda, and then resubstitute back so that you get this point, then use distance formula and find and check if you are getting the answer correctly. Find the vector equation of a line passing through the point 1, 2, 3 and parallel to two planes. This plane is 1x, this plane is 1x minus 1y plus 2z is equal to 5. This plane is 3x plus 1y plus 1z is equal to 6. The fact that these are planes is 1, minus 1, 2 and this is 3, 1, 1, they are the normals. And you need the direction of this line. The equation of a line is always x minus 1 by a. You don't know what is ABC. Is equal to y minus 2 by b is equal to z minus 3 by c. You don't know ABC, but you know this direction. See, look at this. This direction is perpendicular to both this and this. So simply cross I, j, k and do 1, minus 1, 2, 3, 1, 1 and cross it, you get ABC. When you cross the coefficients, you can substitute it back here. So if you draw, it will be very very clear. And plane la plane sum only kadadu, plane la irukradhu plane on normal solittu these coordinates have to be substituted as the normal. Okay, let's go to next question. Find the vector equation. Okay, if they ask you vector equation is r vector is equal to a vector plus lambda times b vector, point vector plus lambda times direction vector. Yeah, the point vector is this point 1 and the direction vector is what you are getting here once you cross. So let's go to 20th question. Find the vector equation of a line passing through the point 1, 2, minus 4 and perpendicular to other lines. If it's perpendicular to other lines, this b vector you don't have, which is a, b and c, you can it's perpendicular, so you can cross the direction of these two vectors, these two lines. What are the directions of these lines? 3, minus 16, 7. This is 3, 8, minus 5. The fact that this line is perpendicular to the line shows that this direction is going to be perpendicular to the line's direction. So just cross these two directions, you will get a, b and c, and then you can write x minus 1 by a is equal to y minus 1 by b is equal to y minus 2 by b is equal to z plus 4 by c. That's all. So just ordinary sum. If you draw, it's clear. Find the prove that the point P, okay, there's an intercept form. It's like x by a plus y by b plus z by c is equal to 1 is intercept form. There's a point P on the plane whose distance from the origin, there's a point on the plane whose distance from the origin is p units. Okay, distance from the origin is p units. Okay, you have to find distance formula then, the point from the origin. So x1, y1, z1 will be the point, and it's normally the equation will be ax plus by plus cz is equal to d, no? So you'll write ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c square is the distance between a point and a plane. But here keep it like this only, because it's not ax plus by plus cz, but x sort of coefficient is a, but here it's 1 by a. So 1 by a into 0 plus 1 by b into 0 plus 1 by c into 0 minus 1 by root of 1 by a square plus 1 by b square plus 1 by c square, mod of itself is perpendicular distance p. So these things and all will be cancelled, and you get p itself is 1 by root of 1 by a square plus 1 by b square plus 1 by c square. And so 1 by p itself is root of 1, so 1 by p square is 1 by a square plus 1 by b square plus 1 by c square. This is what you need to prove. Read the question properly, this is what you need to prove. You have to keep the equation as it is and do the ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c square, but a itself is 1 by a, b itself is 1 by b. So let's go to next question. 22nd sum, the distance between the two planes. The distance between the two planes is, see, two parallel planes. So this is 2x plus 3y plus 4z is equal to 4, and this is 4x plus 6y plus 8z is equal to 12. The fact that it's like this, you know that you can divide this 2 out by 2. So you get 2x plus 3y plus 4z is equal to 6. So this becomes your final equation. Only the distance is varying. Can you see the a, b, c's are same. So the formula is d2 minus d1, distance between two parallel planes, by root of a square plus b square plus c square, for which you should make sure that the a, b, c's are same. So therefore you have to divide the second equation by 2. So it's 6 minus 4 by root of 4 plus 9 plus 16, which is 2 by root of 29. And magnitude, which is 2 by 29, will be the distance between. So you should mug up the distance between two parallel planes. So next is to show that the two planes are parallel or perpendicular, just divide it, no? a1 by a2, 2 by 5 is equal to minus 1 by minus 2.5 is equal to 4 by 10, which is 2 by 5, which is 1 by 2.5. Everything is 1 by 2.5, so then they are parallel. The two planes are parallel. So I am done with miscellaneous. Please go through this video. Tomorrow I can teach you extra sums if you are done and dusted with all this. We must get the book